levels of abstraction. A database system, we know that it is a collection of interrelated data and set of programs to access that data or to modify that data. So a major purpose of database system is to provide the user abstract view of the data. Provide the user abstract view of the data. And this data abstraction, it is divided into 3 levels. See, again, I am repeating, a database management system is a collection of interrelated data and set of programs to access and to modify the data. Now, the major purpose of this database management system is to provide the abstract view of the data. So, this data abstraction is divided into 3 levels. What is the first level? The first level is the physical level. Okay, what is physical level? It describes how data is stored. What physical level describes? How a record is stored, how data is stored. For example, in our case of university, I consider the instructor data or instructor record. How to store that instructor record? That is decided at the physical level. Instructor record, suppose, has 4 characteristics or 4 attributes. ID of the instructor, it is a character of size 8 characters maximum allowed. Then name of the instructor with character, suppose 15. Then department name of the instructor, character 15. Then salary, it is either float or integer. So one instructor record, how it is stored in the database? See, the word important is how. How the instructor record is stored in the database? ID of the instructor as a character, name of the instructor as a character with maximum 15 characters, department name of the instructor with character 15 characters maximum, and salary as an integer. Means the physical level describes how the record is stored. In which format it is stored, that is decided at the physical level. If we consider the student record, how the student record? Student ID, character, name of the student as character, department name of the student as character, and credits of the student as integer. So how the student record is stored? In this way. That is the physical level. How the record is stored. The example already I have told you. Now the logical level. The logical level describes what data is stored in the database. The logical level describes what data is stored in the database and the relationship among the data and handled by only database administrator. And handled only by database administrator. Means what? Instructor record is there. Means instructor table is created with IID, name, department name, and salary. Now at physical level it is decided how it is stored. ID as a character. But what data is stored? For example, F408. Name of the instructor DKJ. Department CSE. And salary as an integer. Okay. So what data is stored? Now who decides this? What data to be stored? Database administrator only decide what data to be stored in the database. That is the next level. We call it as a logical level, and normally simple it is physical. I draw it with the simple diagram. Physical level. Next higher level is logical level. And after that the third level. What is it? It is view level. And view level provide the abstract actual view of the data Means not necessary that every user see the entire database. The views are provided. View number 1, view number 2 and view number n. That is view level. Physical level, how data is stored. Logical level, what data is stored. And view level provide the different views of the data. It is a higher level of data abstraction which provide different views of the data, different parts of the database as view 1, view 2, view n for security purpose. Not necessary that all users see the entire database, and for that purpose view level is considered. So views can hide information. The same diagram is shown here. Physical level is the lowest level, next logical level and view level which provide the views. So views are several other benefits. Views provide a level of security. Views provide mechanism to customize the appearance of the database. Customize the appearance means the person who are allowed or authorized for that data, that only appear for that customer. So that provide appearance of the database, or we can customize the appearance of the database, and a view can present a consistent unchanging picture of the structure of the database. So that is the use of benefit of view level. So in this way data abstraction, it is divided into 3 levels: physical level, logical level and view level. So the next part, that is instances and schemas. When we consider a relational database, the instances and schema, these two words are very important. Now see, first we see what is mean by schema. So the logical structure of the database, is known as schema, database schema. So that is also known as overall design of the database. When we create the schema or the overall design we make, that is very important in the case of relational database. So logical structure of the database is known as schema of the database, or we call it as a database schema. So database consists different set of customers, accounts, all these together is represent logically, that is schema. Now this schema is again divided into 3 parts: physical schema, logical schema and sub-schema. Physical schema, logical schema and sub-schema. So physical schema is the database design at the physical level, means how data is stored. Logical schema is the database design at the logical level, means what data is stored. And sub-schema is a database with several schemas at view level. Now see, this schema is physically independent, data independent. Means what? This question normally asks for the oral. What is mean by physical data independent? So physical data independence means ability to modify the physical schema without changing the logical schema. Ability to modify the physical schema without changing the logical schema. Means suppose there is a table with student ID, name, department name, okay, and in this is the schema, that student ID of type character, name of type character, okay, suppose 8, 15, department name is also character, and this table is created at the physical level. After that, at logical level, data is entered into it, means ID, name, whatever, that is entered. So ID, name and department name. Suppose ID is 1001, name XYZ, department CSE, 102 PQR, department ETC, etc. So at physical level, this schema is decided that what type, what different attributes are there, what is the character, what are the types of these attributes. We call it as a domain. I'm going to explain you the definition of it. What is the domain of that attribute, and at logical level, what data is to be stored. Now, if we want to modify this physical schema, I want to modify means I want to add here a new attribute credits. A new attribute credits. So, ability to modify this physical schema without changing this logical schema is known as data independent, and it is possible with the help of alter command. And it is possible with the help of alter command in SQL that we will learn in SQL. But only remember now that the ability to modify the physical schema without affecting the logical schema is known as physical data independence. That is about the schema. This is the schema diagram for university database. This is the schema diagram for university database. It is the logical design of the entire database. It is the logical design of the entire database. How to draw this schema diagram we are going to learn after the ER diagram. So this schema diagram of university database, how it defines the logical structure or logical overall design. It indicates that there is a student table, there is a course table, there is a department table, there is a prerequisite table, instructor, advisor, time slot, teacher, text, sections, classroom. These are the major tables, or we call it as the entities actually in this database. And each one has some fields. So course has these 4 fields, department has these 3 fields, student has these 4 fields, etc. Along with that, this schema entire logical design, what it indicates that this department name, okay, this department appears here also. This department appears here also. This department name appears here also. Means there is a relation between these 4 tables. Student purchase to this department, or these are member of this department. Course, these are the courses of this department. Instructor, these are the instructors of this department. Means it also shows the relation between all these entities. So that's why it is overall logical design of the database. We call it as a schema diagram. That is database schema. Now the next one, instance of the database. Now see, database changes over time as new information is inserted or some information is deleted from the database. Means this, suppose this is the table, instructor table. When a new instructor is added here, a value such as 95564, some instructor, department, finance with some salary. Then as a new instructor is inserted or new instructor is added, that value need to be inserted into the table. Suppose someone is left the particular university, suppose this instructor left the university, we need to remove it from the database. So database changes over time as information is inserted and deleted. So the collection of information stored in the database at a particular instance of time is called instance of the database. The collection of information stored in the database at a particular moment is called instance of the database. Means at this table or at this moment, how many number of records here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 records of instructor are there. We call it as a instance of the instructor table. The collection of information stored in the database at a particular moment is called instance of the database. Okay. So data models. What is meant by data model? A collection of conceptual tools for describing data, data relationship, data semantics, data constraints. A collection of conceptual tools for describing data relations, data semantics, data constraints. Now, there are so many different data models are available. First one is the entity relationship data model, which is in short known as ER model. So it is mainly used for database design. Next one is the relational model. So relational model is one of the models that is used everywhere or most of the times widely used data model. We call it as a relational model, which is a collection of tables. So these two models, entity relation model and relational model, we are going to cover now. And the object based model, third one is the object based or object oriented data model and semi structured data model, which is XML. So these two models cover in advanced database system. So in that basic database management system or database engineering, we are going to see the ER model and relational model in detail. Then other new old models are there, network model and hierarchical model, but these models are currently not used. These are older models. Now we are going to see only the definition first for ER model and relational model, and then in detail we will see ER model and relational model. So first ER model definition, entity relationship model. So the word entity is very important here. Entity. So what is an entity? Entity is a thing. See, the entity, it's a very important word when we consider entity relationship model. So entity, it is a thing or object in real world which is distinguishable from all other objects. Okay, entity is a thing or object in the real world that is distinguishable from all other objects. Correct. So the simple example is a person. The simple example is, sorry, a person. Every person is distinguishable from all other persons. Every person is distinguishable from all other persons. So simple example is a person. Every person that we know, every person is distinguishable from all other persons. So remember always the definition of entity. It is a thing or object in the real world which is distinguishable from all other objects. Now, relationship. So what is relationship? So it is a relationship between multiple entities. Suppose we consider example, there is a student entity and instructor entity. There is a student entity and instructor entity. So relationship set or relationship is the relation between multiple entities. Now between the student and the instructor, we call a new relation as advisor. So the instructor is the advisor of this particular student. So that is the relationship between the entity, student and the instructor. That is simple definition of entity relationship model. The same entity is a thing And relationship is an association among several entities represented diagrammatically by an entity relationship diagram. In this way, the components and all these things we will see in detail afterwards. So this is the instructor entity, this is the department entity, and this is the member relation between the instructor and department, means this instructor is the member of this department. The example I have given you, student and instructor. So these are two entities and the relation between these two is advisor. How to show it, which components are used to draw the ER diagram, we are going to study in detail. So only here try to understand the definition of entity relationship model. Now the definition of relational model. So as I told that relational model is nothing but the collection of tables. Relational model is nothing but the collection of tables. Collection of tables. Now in this way, this is the example of one table shown here. It is the instructor table, student table, course table, department table, etc. It is a collection of tables. Each table has a unique name. Each table has unique name. Name of the table is here instructor. And this table consists of some number of columns. This table, every table or each table has some number of columns. Each column has a unique name. Each column has a unique name. So in this way, relational model we can define in simple way. Relational model is a collection of tables. Each table has a unique name. Each table has some number of attributes and each attributes in the table has a unique name. In that table, each attribute has a unique name or each column has a unique name. That is about the definition of relational model.